Hi guys, this is Dr. Manjunath Chennapgood from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is science and what are the application of science and what is science and technology and what are the scopes for science we have discussed in detail in previous videos. Dear students, in the today's class I am going to discuss about fundamental forces in nature. Dear students, we know already there are four important forces in nature. First one, gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Dear students, what is gravitational force? We can see the image. What is nuclear force? You can see. Okay, what is electromagnetic force? You can see in the picture. Okay, in detail we are going to study in today's class. Okay, so what is gravitational force? We can say gravitational force is the force which is attraction force between two objects, that is gravitational force. Then second one, electromagnetic force. That force is that is the force which is between two charged particles. That may be repulsive force or it may be attractive force. Then third one, strong nuclear force. That force is nothing but what? The force which is holds the proton and neutrons together, that is known to be strong nuclear force. Then weak nuclear force is the force responsible for radioactive decay and nuclear reactions. These are the four important fundamental forces we are having in nature. Okay, so what all in detail we are going to study what is gravitational, electromagnetic, strong nuclear force and weak nuclear force, dear students. So first one, I will move towards the first force, that is gravitational force. Dear students, we can take a tree. Okay, we can take a tree. Okay, so then the apple is falling down. Okay, apple is falling down with certain height. That height you can mark it as a h actually. So then this you can consider as a earth, dear students. Now we already know this how the gravitation force is calculated, how it is determined. That gravitation concept is well explained and it is invented and well explained by a great scientist, that is Sir Isaac Newton. That we know already how he has done that experiment. You can take whatever the apple is there, right? It is falling down itself, not going up. Why? What is the reason? Because the earth have some gravitational force. Because of that gravitational force, what actually happening? The apple is falling down itself. Okay, then how it is? He has given the reason. He has done a lot of investigation, experimentation, and he has proved that when the apple is falling down, right, there is a force between apple and earth. Because of that force, the apple is falling down. That he has given the concept or fundamentals or principle towards the word. To the word actually. Okay, how he explained, dear students, we can take now. When it is falling down, right, object he has considered apple, it is having a mass m1 and earth having a mass m2, dear students. Now when it is falling down, right, it is falling down because of some force. That force he has taken, he has calculated here now. So now you can take it now. This is m1 and m2, right? Same thing I am going to consider here now. So the object one, you can take apple that having mass m1 and earth having mass m2. When there are two masses, right, if there are two masses, in between these two masses definitely there is a force. That force is nothing but what? Gravitational force. That gravitational force is represented by F, and that force is directly proportional to mass of the two objects. That means what? Mass of the apple and mass of the earth actually, and it's inversely proportional to proportional to square root of the distance. That is, you can take this is apple, right? You can take this is apple and this is earth. The distance between apple and earth is represented as a r. Now so what actually he came to know, that when there is a two object, right, that having mass m1 and m2, right, definitely there is a force. That force we call it as a f. Then that f is directly proportional to m1 and m2. So f is directly proportional to m1 and m2 and inversely proportional to the square of the distance between the two objects, that is r. So therefore f is directly proportional to m1 by m2 divided by r to the power of 2. Okay, r square. That is what he has given the equation. That force, whatever the force is there, that is nothing but what? Gravitational force, dear students. That is one best example we can find in our day-to-day life. One thing, and I will take in second example. You can take a stone. These all are the stone. So what we can do, I will consider these two stones, this stone 1 and it is stone 2. That stone 1 having mass m1 and stone 2 having mass 2. If the two stones are there, if they are having mass, right, that is m1 and m1 and m2. If it's so, definitely there is a force. That force we can call it as a gravitational force. The same thing I will draw the sketch here now. You can see the sketch here now. So stone 1, you can mark here stone 1 and you can mark it as a stone 1, and this is stone 1, and you can mark it as a stone 2. That stone 1 having mass m1, then stone 2 is having mass m2. As I told these students, this is given by what? The great scientist Sir Isaac Newton itself. When there are two objects, right, they are having mass m1 and m2, there is a force exerted by m1 is mass 1 or object 1 or stone 1 is f1, and force exerted towards the mass 1 by mass 2, that is object 2, is f2, whereas the force whatever it is there, right, that f1 is equal to that same force they are going to exert because they are having same mass m1 and m2. F1 is equal to f2, that is nothing but what? F actually. That means what? The force which is exerted between the object, two objects which are having masses, that is m1 and m2, that is nothing but what? F. Then F is equal to what we can say? F is equal to F1 is equal to F2 is equal to G into M1 into M2 divided by R square. That means what? Directly proportional to mass of the two objects and inversely proportional to R distance between the two objects. That is nothing but what? R square. This is what? The gravitational force. That force, because of that force only, two objects, they are attracted by each other. That you have to keep it in mind. The students, this is what Newton, what he has given. One more thing you can take, the block, it is sliding down. Why it is sliding down? Because of the gravitational force. Because of the gravitational force, that force is represented as a F actually. Okay, this is the what? Gravitational force, what we can say in our day-to-day life. You can take any examples, dear students. Okay, all the objects are falling down itself because the gravitational force between two objects. And one more thing you can see now, the earth is moving around sun, right? Because of what? Gravitational force. There is a force between earth and sun, hence the earth is revolving around the sun. Why it's so? Because of the gravitational force. If there is no gravitational force, the earth cannot run or cannot move around the sun. Here earth is moving around the sun because of the gravitational force. So like that you can see here now. You can take, there is a gravitational force. So then what is this gravitational force? That gravitational force is nothing but attractive force between two bodies because of their masses. That is nothing but what? Gravitational force, and it is a weak in nature. Okay, but the force whatever we are having, right, it is a weakest force when compared to other forces. Okay, and it is a long range forces. You can take a long range forces means what? You can take short run. You can take a coconut tree. When it is coconut is falling down, right, the distance we can take 1 meter or 2 meter or 5 meter. Here also gravitational force is also there. Then we can take a plate and earth surface. The distance is 2, but there is a force between plate and earth. That is the gravitational force, but it is having infinite range, but the force is less. That means what? Weak force we can call, dear students. That means what? That force is weak force. And this force is first invented by a great scientist, that is Newton's, and he has given an equation. With the help of that equation we can calculate the gravitational force. How it is, that we can see here now. He is what? Newton, Sir Isaac Newton. Okay, he has given an equation. What is that equation? F is equal to G into M1 into M2 divided by R square. Okay, where F is gravitational force and M1 and M2 are the mass of the object 1 and 2. Okay, so R is the distance between the two objects. This is what gravitational force actually. So this is mathematically first is represented by Newton's, and he has given a constant. Based upon that constant, what we can do? We can calculate the force exerted between two objects which are having mass. Okay, you can take, where you can get? We can get a number of application in earth. We can get any universe you can take if there is a gravitational force. Okay, definition. Okay, what is that? This is what attractive force. There is no repulsive force in, only positive force. Okay, that you have to keep it. Where it is going to take place? Between two objects, mass of the two objects which are having masses m1 and m2. That force is nothing but what? Gravitational force, dear students. That is nothing but a gravitational force. And universal, you can take matter or any energy kind of you can take, there is a gravitational force actually. Okay, strength, long ranged. As I told, dear students, the range from earth to plane or something else you can take, short distance also you can take. The distance is infinite, and it is always attractive force. The force whatever it is there, it is an attractive force. There is no repulsive force in the gravitational force. Okay, these are some factors affecting mass and distance. This is a gravitational force, dear students. Next, electromagnetic force. This is the force which is going to occur between two charges. Okay, and two charges you can see now. What are the two charges? If their charges are different, okay, if the opposite charges, if it is a positive and if it is a negative, then what will happens? They are going to get attracted. When they are get attracting, right, that force we can call it as a attractive force. If the charges are different, if they are opposite in charge, then opposite charges they are going to attract. That is an attractive force. Assume that if it is positive and if it is positive, then what? They are going to repel each other. That force we can call it as a repulsive force. Attractive force and repulsive force. This is nothing but what? Electromagnetic force. This force which is we can get when there are charges, two charges we can see. Then that repulsive force or attractive force depends upon structure of atoms, behavior of molecules, interaction between materials. Okay, and it is what? Long range effect. Acts over a distance. It is going to act at a long distance, and it is a more stronger force. Okay, this is about what? Electromagnetic force. As I told you students, the force repulsive force is going to happen when both charges are same. Attractive forces is going to happen when both charges are opposite in each other. Okay, and this force whatever it is there, electromagnetic force is what? Charge dependent. If the charge is greater, then we are going to get the more electromagnetic force. That is what? Strong force we can get. And it is what? Long range action. It means what? The distance between the force having long range force. Okay, so then electrostatic force can be static case or general electromagnetic force. And relative strength, it is 10 to the power of 37 times stronger, okay, than the gravitational force actually. Okay, this is about electromagnetic force, dear students. Next one, strong nuclear force. Okay, what is a strong nuclear force? Dear students, we can see here now. When there is a nuclear force, right? There is, you can take a nucleus, then there is a proton and neutron. The force which is used to hold the neutron and proton together, that force we can call it as a strong nuclear force. That means forces operating inside the nuclei are called strong nuclear forces. That we can see now. This force, we are going to apply certain amount of force. That because of that force, what we can do, we can hold the neutron, or sorry, we can hold the proton together. That force, whatever the force we are applying to hold, right, that force we can call it as a strong nuclear force, dear students. And it is a very short range force. That is 10 to the power of minus, it is 10 to the power of minus 15 meter. That means what? 10 to the power of minus 15 meter. That is nothing but what? 10 divided by 15. That means what? We will get very small. 10 to the power I am telling now. That means what? 0.0014 it will come. That means what? Very small distance, and it depends upon the charge. Okay, it is an attractive force. Here also it is an attractive force. This is nothing but what? Strong nuclear force, dear students. Okay, so it depends upon what? Depends upon the charge, depends upon what? Proton and neutron. If we are more proton and neutron, we can get more forces. That is more strong nuclear forces. Okay, so this is what? Attractive force and short range forces. Fine. So now last one, weak nuclear force. What is the weak nuclear force? It is the force existing between the two elementary particles emitted during the radioactive decay. What is radioactive decay? That we are going to study in detail in upcoming classes. Dear students, we can see here now. This is a weak force. When there is a radio decay, right? Then what happens? Then weak force is going to generate in the nuclei, that is nothing but what? Weak nuclear force. Actually, the strong means what? The force which is used to hold them proton or nuclei together, that is nothing but what? Strong nuclear force. When the force is going to exist between elementary particles during the radioactive decay. Because of the radioactive decay, there is a force is going to exert between the two elementary particles. That force we can call it as a nuclear force, weak nuclear force. That what is that weak nuclear force? That we are going to study in detail in upcoming classes, dear students. Okay, but when it comes to forces, these are four important fundamental forces what we are having in our day-to-day life. Fine, but not only these forces, we are having other forces also in nature. What are those? You can see applied force, you can see frictional force, tension force, normal force, and air resistance force, spring force. Along with these fundamental forces, strong nuclear force, weak nuclear force, electromagnetic force, gravitational force, we are having other different forces also. Okay, you can see other specific forces. Buoyancy force is also there, centripetal force is also there, and thrust force also there. Based upon the long range forces, we are having gravitational force, electromagnetic force, and magnetic force. These are the different forces. When it comes to, as I was telling, right, different characteristic. What when it comes to spring force? What is spring force? Compressed spring force, stretched spring. Then applied forces. What is that applied forces? The force applied by direct physical interaction. That is nothing but applied force. Tension force. The tension force we can find it in string rope. Okay. Then frictional force is also there. There are two important frictional forces. One is static friction and one is kinematic friction. Then normal forces. It acts on surface or it acts on the object. Then air resistant force that act on object or air. That is nothing but what? Forces actually. Like that, different forces we can get in our day-to-day life. But when it comes to fundamental forces, there are four important fundamental forces, dear students. Okay. I hope you understood the topic what I have discussed. Dear students, here with I request you, please do subscribe my channel, comment and like, and share to your friends. We'll continue next class. Thank you.